Hi everyone, welcome to our class, and today we're going to be looking at finding the area of the sector of a circle as well as the segment of a circle. In our previous video we looked at finding the area and perimeter of a circle as well as the length of an arc, both the major and minor arc of a circle. Alright, so here on our board, and this is my makeshift board, I made this at home, basically on my door. Alright, so here we have a circle on the board. We have the length of the chord here being 6.1 centimeters. The radius is 3.5 centimeters. And for all the radii in the circle, it's going to be the same length. Alright, and the angle subtended by the arc here is 60 degrees. Okay? Alright, so let's just identify the parts of the circle that we'll be working with today. So we have the minor segment, which is formed by the minor arc here and the chord, and we have the major segment here bounded by the chord and the major arc right here. Okay, all right, so let's get into it. To find the area of the sector of a circle, we have to use this formula. So theta divided by 360 degrees multiplied by pi r squared. Now we will notice that we're using the formula for the area of the circle right here. Why? The sector is basically a fraction of the entire area of the circle, and so that fraction is represented by a 60-degree angle, and we know that the total degree measure within a circle is 360 degrees. So hence theta divided by 360 degrees multiplied by the area of the circle, which you're asking what area or what fraction of the circle is being represented by the 60-degree angle here. Alright, so to find the area of the minor sector, we're going to be using the smaller angle, and in this case it is 60 degrees. So where theta is in the formula, we're going to be putting 60 degrees. So 60 degrees divided by 360 degrees multiplied by pi, and in this case we use 3.14 multiplied by 3.5 centimeters multiplied by 3.5 centimeters. So it's 60 degrees divided by 360 degrees multiplied by pi times radius, because when we square a number we multiply it by itself. Okay. Alright, so we can break down this fraction here. So we know that 60 into 60 goes once, and 60 into 360, that goes 6 times. Alright, and there's nothing left to cancel. There are no common factors left in our denominator or numerator. So we're going to go ahead, multiply the numerators together, and then divide it by the denominator that we have here. Alright, so when we multiply, we get in the numerator we have 38.465, and that's centimeters squared divided by 6, and our answer is going to be equal to 6.41 cm squared. So we rounded our answer to 2 decimal places. Alright, so that's it for the minor sector of the circle. Now if we're supposed to go ahead and find the area of the major sector of the circle, alright, we're going to have to find out what portion is represented by the largest angle. Or the larger angle, sorry. So we know that the minor sector is represented by a 60-degree angle. So therefore, the larger angle would be 300 degrees, or the larger sector would be represented by a 300-degree angle, since the total degree measure is 360 degrees. So hence we subtract 60 degrees from the 360 degrees, and that's how we end up with 300 degrees there. Alright, so we're going to multiply by the area of the circle, which is 3.14 multiplied by 3.5 multiplied by 3.5. Alright, so let's break down this fraction here. Alright, So let's use 6. So we know 6 into 30, that's 5. So 6 into 300, that's 50 times. And 6 into 360, that's going to be 60 times. Alright? Let's use 10 now. So 10 is a common factor of both 50 and 60, and it is the highest common factor here. So 10 into 50 goes 5 times, 10 into 60, 6 times. So now we're going to also multiply our numerators here because we have nothing else to cancel or divide through since there are no common factors in the numerator and denominator. So we're going to go ahead and multiply our numerators together. So here we have 5 multiplied by 3.14 multiplied by 3.5 multiplied by 3.5. We get 192.325. So that's 192.325 centimeters squared. And we're going to divide that by our denominator, which is 6, because 6 multiplied by 1, that gives us 6. So our answer is equal to 32.05 centimeters squared. And if we were to find the area of the circle, which would have been 3.14 times 3.5 times 3.5, we would get 38.465 as we can see here. Alright, so if we should add 6.41 plus 32.05, we end up with 38.46 centimeters squared. So this is just one above if we should round this. So we will get back the same thing. So if we add the area of the minor sector and the major sector, we would end up with the total area of the circle. Alright? So now we're finished with the area of the sector. We're going to go on to look at the area of the segment of a circle. Now, to find the area of the segment of a circle, we have two segments in each circle. So here we have the minor segment and the major segment. Alright? So to find the area of the minor segment, we're going to have to subtract the area of the triangle here from the area of the sector of the circle. So for the major segment, we would subtract the area of the triangle from the area of the major sector. Alright? So we're going to have to find what is the area of the triangle given. And we can see in this case that we're given the length of all three sides of the triangle. And we would have learned that to find the area of a triangle when the length of all three sides are given, there is no perpendicular height there. So we would go ahead and use what is called the Heron's formula. So in using the Heron's formula to find the area of a triangle, alright, we will first find the semi-perimeter. And we know that the prefix semi means half of. Alright, so we're going to find half of the total perimeter then. So 3.5, that sounds redundant, but anyway. Half of the perimeter would be 3.5 centimeters plus 3.5 plus 6.1. When we add that, we get 13.1, and we divide by 2, we end up with 6.55 centimeters. And that is a semi-perimeter. And I use a small s here to represent the semi-perimeter. Now, after we have found the semi-perimeter, we need to now go ahead and substitute the semi-perimeter into the formula for finding the area. Now, to find the area of the triangle, we would now have to find the square root of the semi-perimeter multiplied by the difference between the semi-perimeter and the length of each side of the triangle. So when we subtract 3.5 from 6.55, we get 3.05. And we would have seen that 3.5 is repeated. So we have two sides of the triangle having that same length. So we have 6.55 multiplied by 3.05 multiplied by 3.05 multiplied by the difference between 6.55 and 6.1, which is 0.45. Now, we're going to multiply all of these numbers underneath the square root sign. Now, when we go ahead and multiply all these numbers, we end up with 27.42, and this was rounded to 2 decimal places. Then now, since we have just one number beneath the square root sign, we are going to now find the square root of 27.42, round our answer to 2 decimal places, and we end up with 5.24 centimeters squared. Alright, so that's it for the area of the triangle. Now, I'm going to just erase the circle for a bit because we need some space. We can get this. Alright, now, as said before, to find the area of the minor segment, we have to subtract the area of the triangle from the area of the minor sector. So it's the area of minor sector minus the area of the triangle. Alright, so for the first one, for the area of the minor segment, we're going to use the area of the minor sector, which we worked out to be 6.41 centimeters squared. So that would be 6.41 cm squared minus the area of the triangle, which we found to be 5.24 centimeters squared. And our answer is 1.17 centimeters squared. So that's it for the area of the minor segment. Now for the area of the major segment. We're going to have to use the area of the major sector that was found to be 32.05 centimeters squared. Subtract the area of the triangle from that to find the area of the major segment. So area of major, and I write MAJ for short, sector, subtract area of the triangle. Alright, so we end up with 32.05 centimeters squared minus 5.24 centimeters squared. Alright, so 32.05 minus 5.24, we get 26.81 centimeters squared. So the area of the minor segment is 1.17 centimeters squared. The area of the major segment is 26.81 centimeters squared. Alright, so thank you guys for watching, and I hope you learned something, and I wish for you a blessed day. Thank you very much. Saying bye-bye.